Okay, we're in section 6 of the notes now, and certainly I'm looking at the computer algebra code. Certainly, we've gone over this, for every section so far, and I'm hoping that you're getting a little bit more familiar. Not that you're memorizing things. We really don't think that's appropriate. A lot of times I forget code. I have to look it up again. I've known professional coders that actually keep what's called the cheat sheet next to them, which, you know what? Maybe I should talk about that, cheat sheets. It's nice to have a cheat sheet somewhere. Now, someone says that's a really bad word, cheat sheet. People use them. They need some kind of, method to remember things, and they try to summarize it. And this is going to say a weak thing for a lot of students. What you need to do when you're studying material is create what's called a cheat sheet, not to take it to the exam, but things you write down in one single sheet of paper, things that you can't remember, right? Let me just briefly go through that with you about what a nice looking cheat sheet would look like for Sage. And again, I'm gonna go back to my website, and I'll point this out to you. Sage.mathography, right? That's my website, by the way. So let me just kind of look through over here, my guidebook, projects, again, my guidebook, website, let's see, free book. Oh, cheat sheets, look at them right here. So Sage quick reference. Let me click on it. Now this is like one single sheet of, oh no, it's not single sheet, two pages long at this point. All right. And by the way, this is really characteristic of what a cheat sheet should look like. Well organized. So if I were a Sage coder, right, I might have to, have a cheat sheet out. Now, I'm not saying we know a lot of commands at this point, but we know some, right? We know some, not a lot, we know some. All right. So you may want to have something like this around. Now I'm going to just go back, and there's a cheat sheet for linear algebra. If you're taking linear algebra, I would recommend you start looking at the cheat sheet for linear algebra. Now, by the way, linear algebra is a really, really big subject area. It's also a very abstract, very difficult subject area. There's a lot of code that can be done with Sage for linear algebra. All right. But again, the guy has basically 2 sheets of material that he needs to know for linear algebra. Now, if you go back, number theory, well, we really don't do number theory. That's kind of college. Calculus quick reference, that's what we're doing. Basic math. By the way, you may be surprised what basic math looks like. Let's take a look. And someone could say, my God, this is basic math? Yeah, it's basic math. All right, basic math. All right. And then, graph theory, abstract algebra. Things you may or may not be studying in the future. Who knows where your future is going to bring you? All right. Your future is going to be dependent on your past, though. And your past really is dependent on how much time and effort you're going to put into your studies for your future, by the way. So I'm going to close that out, and I'm going to go back to my Sage code. All right. So I don't really need a cheat sheet here. I can just type in my Sage. So reset. I've always done that, by the way. X the variable. And what's the variable? The variable is X. And you might be surprised. You can start calling variables like in computer science, like whole names, like call it Bob if you want. I don't think it's a good idea when you're doing calculus, but or algebra. F of X, what's that? I'm going to assign it, just like I assigned X, I made it a variable. I'm assigning F of X to be 27 minus X cubed. By the way, the Sage code here has something to do with the material from this section. And we're hoping you can recognize that. And G of X equals 27 minus 9 star X. Remember, I got to put the star in. And I'm going to plot that. Before I plot it, what I want to do is solve. I'm going to solve. Where does F of X? And I'm depending on my past, by the way. Do I remember my past in this? And I'm going to solve for X, see what happens. Who knows? Maybe I can't do it. Oh, it says it's between, it says there's 3 points of intersection, -3, 3, and 0. Well, I'm going to plot it now. I'm going to plot PLOT. I don't know. I guess I could plot F of X. I guess I could plot G of X, right? And that's 2 functions of graph. I'm not sure what the problem's about at this point over here, but that's because, maybe I can't remember what this problem's about. Maybe it's just simply just something they're asking me to type in, see if I can figure it out. Now I'm looking at between -3 and 3. So I'm going to say X goes between minus 3.5 and 3.5 now. Someone's going to say, can you do that by hand? Of course I could. And what do you get? You get a primitive object that looks like this over here. All right. So I'm going to go to the next line of code. I'm seeing that. I'm seeing the green curve. The green curve is just a line. This blue curve is the cubic. What am I noticing about this? The green curve is above it between -3 and 0, and the green curve is below it between 0 and 3. All right. I'm definitely seeing bounded regions over there. They want me to integrate and put this down for you. Whoops, sorry about that. I got to close that out. Integrate. And I'll go back over the notes for you. And they want me to do 2 star pi. Again, if you're blindly typing in with no understanding why you're typing, that's not good. Whoops, I forgot to put the X there. Star, and then they got f of x. We'll go back over the notes in a moment. Minus g of x. And they want me to go x between 2 numbers. And I'll put this over. Your x is, what is it? Oh, 0 to 3. That's nice. Again, if you make a mistake, Sage will gently let you know you made a mistake. And I make mistakes all the time. I didn't make it. I got the answer. So what I want to do is, again, I say there's a connection between this code here and what we do by hand. I'm not sure if it was a homework question, an example we did in class, or maybe just part from the lecture. I don't know. So we'll look back over it. And I'm looking for that 27 minus x cubed. And yeah, it's annoying sometimes to look back over stuff. It's not in the homework. Wow, it's example number 1, stuff that we did. All right. So I'm seeing, 27 minus x cubed. I'm seeing g of x equals 27 minus 9x. How we've done this class, probably graphed it out, probably looked at it and used the shell method. If I did that, and we did cover this in class, by the way, I would get an integration that looks like this over here. Yes, I would have done that in class for you. Yes, I would have provided a graph for you. Yes, the point of intersection, and we would have set the integration up. Then what do we do in class? We expanded this thing, we did the integration. And at the end of the integration, we got 324 pi over 5. What does Sage give me? 324 divided by 5 times pi. Again, a lot of students misread this, thinking it's 324 divided by the quantity 5 times pi. It's not. It's 324 divided by pi. I'm sorry, divided by 5 times pi. This is why you need to start looking at handwork and computer algebra system work to get the connection between the two. There's a connection. All right. Thank you.